Good day, everyone. Um, for today's lesson, we will unravel the world of related, rate of change. Pero slight lang. Anyways, my name is Mario Guao, and I am a Bachelor of Science in Education, major in mathematics student at Agusan del Sur State College of Agriculture and Technology, or ASCAT. Um, what am I about to show you is some tutorial on how to deal with the related rates. The rate of change rather. So it is just an introduction to the topic, but hopefully I will make another video for those difficult examples or semi difficult rather. So, as I have said earlier, that this is just an introduction to the topic. So, let's open my PowerPoint presentation, which is the entitled Rate of Change. So, by the way, what is rate of change? Rate of change is the change of y over the change of x, or where y represent as the dependent value and the x represent as the independent value. Or simply, the rate of change is equal to the delta y or the change of y all over the change of x. So here's an example. A climber is on a hike. After 2 hours of hiking, he is at the altitude of 400 feet. And after 6 hours of hiking, he is at the altitude of 700 feet. What is the average rate of change? So, first we need to do is look for our y value or the dependent value, which happen to be the altitude. Of course, it is the altitude because the altitude depends on the our independent value, which is the time. The time goes on whether you are sitting or you're just lying down around there while watching this video. The time won't stop. So it is always the independent value. So to solve for the change of y or the delta y, 700 minus 400. Therefore, the change of y is equal to 300. And to solve for the change of x, which is 6 hours minus 2 hours, so um what you call this the change of x or the delta x is equal to 4. So by using the formula that I have shown to you last slide, and using the value that we have after we have um, solved the dependent value and the independent value, we have rate of change is equal to 300 uh, 300 feet over 4 hours, or simply 75 feet per, per hour. So that that will be the answer. So for the example number 2, determine the average rate of f of x is equal to x squared plus 4x minus 5 on the interval 1 and 3. So the average rate of change is equal to the delta, the f of x f of x minus, bakit ganito to? I don't understand. Wait. Okay. The average rate of change is equal to f of b minus f of a all over b over a on the interval a, b. Whereas our f of b is equal to f of b of our x squared plus 4x minus 5 is equal to 3 squared plus 4 times 3 minus 5. So just substitute the value of 3, rb, which happen to be rb, on the function. So by solving for f of b is equal to 16, and for f of a um, replace or substitute the value of 1 into every excess on our original function, which happen to be 1 square root of 1 plus 4 times 1 minus 5 is equal to 0. So our for solving for our f of average rate of change, I forgot to make let's make let's solve for the rate of change. So therefore our average rate of average rate wait, our average rate AVR is equal to 16, that's 16 minus 0 all over our interval, which is our 3 minus 1. So therefore 16, 3 minus 1 is equal to 2. So therefore the average rate is 8. 8 is the answer. So guys, when we say average rate of change, it is tumutukoy ito sa second line, the I mean the slope of the second line of the function. What do you mean by the second line of a function? Here's an example. Let's say we have a Cartesian plane here and a function x squared, or the second line passes through the 2 points of the function. That is the second line. However, this one is the, what do you call this? Yes, the tangent line that passes only 1 point of the function. So again, the second line, no, the rate of change is the slope of the second line. So that's all. Maybe that's all for now. Maybe for the further future, I will make another video about rate of change. So good day and have a nice day.